Determining the energy of a reaction using Hess's law. Hess's law is a method of determining the delta H of a reaction using a given set of reactions. The general principle is that if we can combine the given set of reactions to produce the reaction we want, then we can combine the delta H's of those reactions in the same way to get the delta H of the reaction we want. Suppose we wanted to find the delta H for the reaction 3C2H4 gas plus 3H2O2 liquid gives C6H6 liquid and 6H2O gas, using these three reactions. To begin with, we need to try to locate the substances in the reaction we want somewhere in the three reactions that are given. We need to try to locate a substance with the same formula and the same state. We want to find the compound C2H4 gas in the reactions we are given, and we do find it in reaction 1. We want to find H2O2 liquid, and we do in reaction 3. We find C6H6 liquid in reaction 2. And we find water vapor in reaction 1 and reaction 2 and reaction 3. In general, when one substance appears in more than one place, we do not use it unless absolutely necessary. This leaves us with three substances, one in each of the three reactions. Now we need to make the substances in the given reactions match their counterparts in the reaction we want. We need to do this in two ways. First, we need to have the two on the same side of the arrow in the equations. If the two are not on the same side of the arrow, then we can make that happen by reversing the given reaction. Second, we need to have the same amount of the two, that is, the same coefficient. If that is not true, we can make that happen by multiplying the given reaction by some factor to make the coefficients the same. In this example, the C2H4 is on the correct side of the equation, so we do not need to reverse the reaction, but the amounts are not the same. We want there to be three C2H4s, but the given reaction has only one. So we need to multiply the given reaction by 3 to make that happen. Remember to change the value of delta H by multiplying it by 3, and to multiply all the coefficients in the reaction 1 by 3. For C6H6, the substance is on the wrong side of the equation, but it does have the correct amount. To correct this, we need to reverse reaction 2. Remember that this will change the sign of delta H. For the H2O2, the substance is on the wrong side and has the incorrect amount. So we need to reverse reaction 3, changing the sign of delta H, and multiply reaction 3 by 3, and do the same to delta H. Making those changes, we get, note that we have 3 C2H4 gas on the left in the reaction we want to make, and 3 C2H4 gas on the left in the changed reaction 1. C6H6 liquid in reaction 2 now matches where it is and how much we have in the reaction we want, with 1 in the products in each place. And there are now 3 H2O2 liquids in the reactants, both in the reaction we want and in reaction 3. Now we need to add the reactions together to confirm that we actually get the reaction we're interested in. We can cancel out those things that are the same on both sides of the arrow, like the 6CO2 gas, which appears on the right in reaction 1 and on the left in reaction 2. Those will cancel out completely and not be a part of the overall reaction. We have 3H2O on the left in reaction 2, 3H2O gas in reaction 3 on the right, and 6H2O gas in reaction 1 on the right. This means that we can cancel out 3 of them, leaving 6H2O on the right. We have 9O2 gas on the left in reaction 1, and 15 halves O2 gas in reaction 2, and 3 halves O2 gas in reaction 3 on the right. 15 halves and 3 halves add up to 18 halves, which is 9. So the O2 will cancel out completely as well. This leaves us with only 4 substances left, so we write them down in a reaction. Note that this is exactly the reaction we are looking for. The number of each compound is the same and the state is the same in the 2 reactions. This must be true, or you have done something wrong. Once we have confirmed that we have made the reaction we want, then we just add the 3 delta H's to get the delta H for the reaction. Now some general comments about the process. Because there are a number of reactions involved, and you do different things to each reaction, I strongly recommend that you do the process in 3 distinct steps. First, identify the substances in the reactions you are given and determine what must be done to the reaction. Write this down next to the reaction. Second, rewrite each of the reactions, making the changes you have determined must be made. Don't forget to change delta H, and don't forget to multiply all of the coefficients, not just the one substance that you are focused on. Third, cancel out what can cancel, and write the rest of the substances down in a reaction. Confirm that this is the reaction you want, and then add the delta H's together.